implement by hand this, and then I will show you ways how to do this more already with pre-made stuff, and then we will start using it for the intended reason. So, okay, the data set which is included in the template, I think it's one data set which I made like a year ago or something, like regarding the fruits. So there's different kinds of apples need to be classified, but of course the way to classify the different kinds of captcha letters or things like that, that is at the end what we want to do. So if I see the code, let's see if it happens if I try to run it. So okay, it's not on the screen, So initially it downloads the dataset first. And then it fails at the loss function. Okay, so the loss function is the place where it fails. The loss function. Okay, I think you will be able to implement loss function yourself. But let's see what else. There is the model. Model is empty. Okay, and then the convolution. So there is also batch norm. We will look at the batch norm as well, and max pool as well. So max pool and batch norm also are very useful tools in these models. Okay, but then the first one is the convolution 2D. So this is that function.
Sorry.
Yep.
There's a problem with the imports.
TDQM. Okay. So maybe what you can do with that. Okay.
But also torch vision is not.
Yeah, torch vision as well. Arch. So let's see what's up with torch vision as well. Okay, torch vision not used in this one. By the way, torch vision could be also. So to install these guys, you can use the package. So this one, see, Python packages TQDM, and then here select and install. But in Linux, Unix, Mac OS systems, it's very easy from the console. In Windows, I don't know why, but basically here, if you press in the bottom Python packages, you can easily add those. Also, you can add the torch vision if it's missing. Torch vision here as well. So the TQDM library, that is for the kind of in console. There is a very nice progress bar that shows how fast your model is training, and yeah. So this panel is here in the bottom. So here is the Python packages. Python packages panel in PyCharm in the bottom side. You can try to use it.
No need for the command line.
So are packages okay right now, or should I help anyone with the packages? So is it possible to run your code is like not crashing due that you don't have some package? Okay, so if I hope that you get through that step, then afterwards you should move to conv2d module.
I'm getting another error message.
Okay, well,
line 250.
What is the error message?
Int object is not introduced backward.
Yes, that is expected.
Okay.
That is expected because that one is not yet implemented. Oh, sorry?
We were just talking.
You don't have what? Yes, that is the problem. You have the GPUs and it's trying to I will explain. Okay, actually that's interesting problem. Usually when I run these experiments, people don't have like CUDA enabled devices. So here, if you just comment out these lines, please. So if you will run it without these lines, comment out, you will run all the model on GPU, and first of all there is the max length 0, so whole dataset will be used, not just like some sample of the dataset for the training, just like, and then on the GPU device it will be run. So if you will do that, we will have some problems. Now we will do this a little bit later. Yeah.
Yeah, I don't know.
Yeah, so please do what I've showed here.
Yeah.
So just comment out the if torch CUDA. So what can I help? Yeah, so go here and packages and install.
Okay, so if that works like properly, then I need the
again, like please comment out the device CUDA. So this because I forgot that you have the GPU devices. So that is proper way of training on GPU, you know. But we will do that a little bit later. So now we are at the Con2D. Okay. So what we have over here, that will be interesting. So let me think. What would be the good way to do this? So, okay, we can make a dummy code below. So all these programs can be also tested really nicely with some dummy code. So I will write this Con2D, and I will say that in channels are three channel picture, RGB color picture, right? Out channels, I want 4 channels as output. Kernel size, so in this case we could have like kernel size different for each of the dimensions, but let's say that this will be the same for both dimensions. Then stride will be 1 and padding 1, so this is kind of the standard configuration. So we can try some small dummy code to make sure that this works. Just a second, I will make sure that I don't need to rewrite it 3 times. Okay, torch ran n. Okay. So and then let's write the input. So x dummy will be torch rand n, and this will be the size of the vector which we want. So first one will be batch size, right? So then the next one will be the number of 3 channels, and then the image size will be 64 by 64. And finally there will be y dummy, which is the Con2D forward x dummy, and afterwards we can kill the program by calling exit. So this is actually good way to test a lot of deep learning kind of functions, just to create some kind of small dummy code to run it to see if everything is as you want it to be. So right now, some things to keep noticed is that there we have the red, green, blue channels, not here at the end, but in front. So normally, like if you load PNG or something, they have this on the other side. So it's just swap dimensions. So that's one. And other otherwise it should be obvious. You know, batch size, that is always in the front. All axes have batch in front. Then the channels, then the width and height. And yep, so that's that.
And what exactly are you testing in this case?
So first of all, see, there is the forward. So I created the instance. So this notation is the same as in the C language new object. C
So you
sharp
created
C++.
your object, you
Yes.
passed your test values, obviously,
Yes,
the random values,
yes.
and what
So what we want at the end is to get out here the shape of the matrices that follows that equation, which I showed that it has the correct dimensions, right? Plus also that there are not like some errors or something fails, you know. So let's we cannot really this way we cannot validate that there is the analytical part is exactly right, that there's maybe some you know, it's not training it and it's not training. Maybe there is some more problems, but at least half of problems can be found out.
Yeah, I already have an error.
Let's see. So okay, let me see. So if I try run it as well. Yeah, I guess what is this? I don't have TQDM. What? Maybe I uninstall it myself. So pip install TQDM. Oh, it is here. What is up with this? Debug. What is this? Maybe I somehow damaged this. Ah, yeah, I damaged this. Sorry. Okay. Now it will work, hopefully. Okay, so now there's some different error. Ah, okay, yeah. So this one, that is good. Okay, so let's keep working here. So then the shape of the kernel itself. The kernel is the small matrices that is going around the feature the feature map. So that small guy, this is the square, or it cannot be also square. It can be something else. So we need to define the size of that thing. So the way how we usually define the size is basically, again, we want to use the dot product, so you will see in a second. So first of all, the one is the kernel size. Okay, by the way, how it was the definition. Yeah, so the kernel size, comma kernel size, and now comes the in channels, and then goes the out channels. And this is really interesting because, like, one way would be to add additional for loop where we only have the what we could have is basically without these two guys, just so let me show you what I mean by that. Or actually not the in channels. So maybe if we just have that kind of kernel times n, so we have like many like that, and then we for loop like in that animation, right? So in the animation, the idea was that there are like these separate kernels, and then we sum them together. And here, because of the way how dot product works by the last two dimensions, we can just combine that procedure and make sure that on all of these areas where the kernel size is executed, the last two dimensions will always execute the dot product, and the shape of input will be the shape will be changed to the shape of output. That is perfect what we need. So that's first. Then another thing is this line. This line is also very interesting. So there is the torch and then init, which initializes the values. So normally the values are either most likely random in the sense that they're not initialized. So whatever is in the memory, let's take those values. That is the way the C works. If I create the C array, like of floats, you will see that there is all sorts of garbage data inside. You cannot. That's something to remember. Like in C# when you create or some kind of Java or whatever, create a new float array, then the values will be inside zeros, right? But if you create in C language, it will not be zeros. And here, similar idea that initially we don't guarantee that there is zeros, but then we initialize it to some specific value. So now we're saying, let's make it uniformly random. That's good. So far, so good. So then we have the kernel ready. Now we just need to calculate the actual for loops for like making the kernel walk around the whole feature space.
What's the
Yeah, so the uniform distribution is just that so there is basically kind of two big ways how to do the randomness. One is the normal distribution, you know, like the bell shape, right? The uniform is everything all the same, about equal, and then the chiming is kind of like variation. You can also do the chiming normal distribution. I can look up what is the exact difference. They have some variation in the equation. Chiming distribution.
I don't need to know it in that such detail.
No, but it is good good stuff, because as soon as so that they published it, I think only like few years ago, or like maybe maximum like 6 years ago, or something like 5 years ago. And then when they published it, they showed that that kind of equation was much more stable for bringing better convergence for the models, and then everybody started using chiming everywhere. So, but you can look up that then later. So okay, so this part. Okay, let's do then first practice. So here there is the get out size need to be implemented. So what is get out size is actually that equation which we had on the Jamboard. I will show you. So that's what you need to implement now. So just a second. So please go here and slide number 3. And in slide number 3 we need to implement this guy. So I believe you should do this with your eyes closed, right? That's all good in Python. So it's like very simple way to implement, you know. So please try to implement this small equation. So again, the reason, so we could actually, implement this equation, and the task is following. So we need to know what will be the out size depending on in size. In size is basically the image size, or the feature map size. And now the out size is what will be the width and height of new image after this kernel operation, which we will implement in just a moment. So, and you see you need to implement it, of course, here, right? So then to check yourself if you did everything correctly, so the kernel size 3 stride 1 padding 1 should produce, so if this is correct, then basically in size must be the same as out size. So print f, so I'm just writing it for myself, is correct. So this is correct when, so this is actually what it is. Okay, so that is just a scalar value. So yeah, all those the same. With this particular configuration, right? If I just change the kernel size or stride to something different, it will not be correct anymore, right? So so just for you to check it out. So here, please implement this very simple equation. That will let me know. I'll also understand how proficient you are now with the Python. You know, on the slide number, which was the slide, I will show you. It's not that difficult. So, slide number 3. You need this equation implemented. The number size in, padding, kernel, stride, implemented. And the reason is we want to know how smaller will be this new map, and we need to track the size of this map, because at the end we want to know what is the end map, which we can then flatten. So the flatten means I will take all of these like rows and put them in the long sausage, you know. So that, and we need to know the size of that sausage. Okay. So can I help them now? The line. See, there is this one function. Go down a little bit. So here, by the way, you can have here I tried this one, exit, so the kill program is placed. So it doesn't go further, right? So now it will be killed at this moment. And inside this function, you see there is a get outside. Actually, it's calling that function which you need to implement. And if you want actually to see what's happening inside, remember that on the left side you can click those red balls, right? On this area. Yeah, so try to click here. Yeah. So now if you try to run with the plugin, kill. Cancel.
No.
Yeah.
You sure about that?
yeah, it should stop there. If everything goes well. It's not connected.
Get out my
Okay.
line 100.
Interesting. So also missing. Yeah, you're missing pattern.
I'm writing, so it's
Padding one.
Mark level.
It will give you already. Yeah, see padding one. Try run again with the bar.
Yeah, I think I could also use and your camera
Yeah, go back. Okay, I will actually add this to the Jamboard because maybe you missed it. So go back to the conv. So I'll show you that. So here there is the one way to enable easier work.
hopefully it's good because I
Back very quickly.
copy it.
Here you're missing this part. I will add this on the So I see that some people missed the implementation of the kernel size. So I will quickly add this also to the Jamboard. So let's make this smaller now. So here I already did this part, so I changed the kernel size. Please change it also for yourself to make this work. And that meanwhile, I will try to see how well are you doing with the implementation. Okay.
Can you
Yeah, just yeah. This is afterwards.
do you know what he changed? I think he just implemented the
Just use wait, nothing is rounded. It always goes down. So just in. Yeah. Yeah. Okay. Yes. So okay. So this
plus one.
So this doesn't mean ABS, by the way. So it's tricky. I know this is stupid. So see here on the top part there is no that stingy, and the bottom part there is. See, it actually means floor.
Floor. It's floor my division.
Yeah, I mean like it's so no, but it's nice. So it means that like round to lower number.
So it's correct again.
We'll see. So yeah, I think so. But again, you can use just the build. Not you can use NumPy. You can build built-in function as well. Okay. Yeah, I hope it's working. Okay, cool. Except you know that you need to put this in some variable, right?
Yeah.
Because now it's just campaigning me. So
Yeah.
cool. Yeah. So. Yeah.
Putting this in a variable.
All right. Yeah, I like your approach. Do you know Python well?
A little
Yeah.
bit.
So you know this one, right?
I know it because I checked the last code templates yesterday. So.
Oh yeah, that's a neat trick. So
This
yeah.
guy, he knows.
The German guy was
You
always
also
coding.
know this. You look at some template, yeah, or you know double slashes. You know double slash. You all look from here. Okay. So in Python there is also a really neat way to write the floor function. So just with just a double division sign. So that is nice. So we can implement it together. Just a second. So here on the top part where we need this formula. So what we can do is it's actually also would be nice to have it like separated in multiple parts, but we can just write it as that result. So here the top part, in size, plus 2 times padding, 2 times padding, 2 times padding, minus k, and then you can do this. So let's try it. So it looks nonsensical but basically what it does, it just does the floor of that division. So it is division without reminder basically. So plus 1. So this is the Python div without reminder, opposite of basically modulus. You know, modulus opposite of this guy. So or floor. Basically that's the same as floor. Okay, so this is this. Then return result. So that's good. I'm adding this also to Jamboard so that everybody can catch up. This on the slide number 4, I guess. Yep. Slide number 4. No. Let's remove it. Now let's keep then digging into those like arrangement things. Okay, so first we need to apply the padding. Right? We can actually first we actually can use our new out size. We can produce the result here. So so the out will be kind of template of our return result. So this will be zeros. Zeros means create me a matrix with that kind of dimension. So it will be the batch size, comma, the self out channels, comma, the out size. So this will be the result which we want. This will be empty matrix which will be filled later. To device is necessary to enable that this code will later work on GPU as well. If we don't add to device, then it will not work on GPU. From other side of view, maybe we okay, let's forget about to device. Let's not make it workable on GPU. On GPU, we will use a little bit more powerful models. So that's that. What else we need here? The padding out size is already included in the padding. Right, we need to pad the initial image. So x padded. So we need to pad the initial image. Let's make it that by default it is not padded, but then if self padding is larger than 0, then in that case we want to have it padded. And the size will be a little bit different then. X padded will be, again, let's then create the torch zeros, and then we will put in the real stuff here. So batch size, comma, self in channels, and then the in size plus self padding times 2, and this is 2 times. So this is then the actual image which will be fed in the algorithm, because beforehand so we need to add the padding if we want. So x padded. Now this is just a 0 matrix. There is nothing inside there. We need to put the original image in the center of that stuff. So and then to do this we need to copy the batch dimension. We need to copy the channel dimension, but we don't need to copy the width and height. So self padding till minus self padding, which means that I want to cut out only that part. Self padding times self padding minus, and then we will store there the x inside. Hopefully that works.
How many self paddings?
Sorry, just a second. Yep. I think that's about it for the padding. So the idea is that maybe if you know better way how to implement this padding thing, try your way. Maybe there is even the function, and there might be function torch pad or something like that. But basically, it's a idea that I created the matrix, which is a little bit larger, and then copy in this box the original x inside. Is it clear, right? Again, so here the minus thing. So there is a colon and minus. So minus, maybe it's also not that easy immediately to understand. But in Python and NumPy, it's very nice to have that idea that I can select variables inside the array starting from index till the end index, right? So from this index to this index. And if I add minus, it means from the other end, take some indexes and select that part. So it's very, very convenient way. Plus also it's very convenient that if I select here kind of like a box, right? Then I can just put in that box the other array, which is the same shape. So it must be the same shape, then it works. So I will add these padding calculations also to the Jamboard, and then we will move on to the bigger piece of code, which is the actual for loop for the calculation.
Do you still want to return out with the value of x or with the value of these paddings?
Now, x pattern is the input for the algorithm, right? The out is actually the matrix which will come out. So the input is also modified because we need to add padding, you know? We modify the input to have the padding as well.
But where do we use this modified input?
You'll use it now.
Okay.
So then this last line of out we can delete, of course. So now let's write the I out. So this will be the dimension for tracker for I out, and then there will be the tracker for the I in. So I in. So this will be the kind of X position, so in range, and we will be able to use the nice feature for Python to have the range with multiple parameters. So the range of 0, comma, X, wait, the size of the padded matrix, just a second. Size of the padded matrix, we can do this. X padded, padded, size 0, so no, it's not 0, -1. Oh no, wait a second. Okay, outside, yeah. Oh, it is the correct size padded. Oh, I really don't like that calculation. Just a second. So let's put it as a separate variable. So the I and so I in and so this is imagine the kernel what travels around the image. We need to know where the kernel should stop traveling. So the kernel should stop traveling if it reaches the end of the image, right? But then there is a problem because the kernel is not just one pixel. The kernel is actually the kernel size. So we need to minus kernel size. So that's an n. And then also -1 because the kernel itself. So yeah, so it's excluding that part. So it's not including so the upper bound of for loop is excluding that part. Or not, sorry, +1, not 1. I think so. Maybe I'm wrong. Anyway, we'll see. So like that. And then we need to have a stride. So self stride. So this is that kind of cursor or tracker where we want to look in the X matrix and where we want to look in the out matrix. So one is in, one is out. So J out also equals 0. Then the J out is kind of the same as J in because we are working with these square matrices. If we would work with different kind of size, then these could be different as well. So, and this is J out. Okay, J in, sorry. Oh man, so J in, that's good. Then we need to select out the actual X chunk. So the chunk to which we want to focus our attention. So this will be from X padded. We select the batch channel, and then we select the. By the way, I'm going a little bit fast now because in 5 minutes I need to run out for 10 minutes for another call. Again, I'm very sorry that I'm disrupted today because of all of these unplanned situation, which I didn't want to come today to do this, but we'll get there. I will help as much as possible for you to understand as well when I come back. So J out. So this is the block. This is the block where we select out this small part of the image. So we select out this small part. That is good. Now we need to calculate this dot product between that K matrix. What I suggest here is so with the batch dimension we have ting 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 batch dimension. So batch dimension -1 -1 everything else goes there. Okay, so we'll need to try to make the dot product would work only on those last two dimensions. Maybe we'll do this just a second. Because at the end we will insert, so actually maybe it's easier to see like this way. So we will insert our result into out matrix, all batch, all channels at only at one pixel, basically at one location here. So the shape that we need here, so this is then the out chunk is actually, that shape is really specific, so it should be the batch comma channels comma 1 comma 1. Right now the chunk shape is y chunk equals the, so this equals the batch channel kernel, then the kernel self kernel shape equals to, what is the kernel?
Can you move the code a little bit up?
Oh, sorry. Yeah. Okay.
Yeah, thanks.
Kernel. So then the channel in, channel out. Here is the channel in. Here we need the channel out. So that's great. And what we actually need then is to have the dot product. So there is the KK. Oh yeah, we need to eliminate also the K, unfortunately. So the K must go. The K must become as 1. Think how we could do this in this context. Need to sum them together. Okay, my idea is that we could reshape the X chunk first of all. The X chunk could be then reshaped as X chunk is this thing. Is the channel the second one? Something is off here. size. Oh no, it's fine. So yeah, I know how to do this. So let's do it. So this will be then the -1 times, oh no, batch size times -1. So this includes the combination of C in times K times K times K times K. In that -1 is inside that part. There's like basically batch comma this thing. So this is good. Then the K in terms is again self reshape or self K, sorry, U U, so this is the K -1 self out channels. I think it was the last dimension there. So it is the last dimension, yes. So it is then the, yeah, so this is great. So these guys are coming in here, and in this thing we have C out. So now it makes totally sense. So we need to do the dot product between these guys. So we need to have out chunk to do the dot product between the so the K K. Okay, I will just quickly try to write it, and then you will try to make it while I'm away. So consult with each other to help out. So again, there's one few small tricks I need to quickly mention. So one is that actually there is a two-dimensional guy. This is two-dimensional. This is one-dimensional. Because the batch, we ignore the batch, right? So basically you need to create this to the two-dimensional, expand dims to 2 dimensions, so that there is one extra dimension. So just a second. So this is actually 2 to 3 dimensions. So we need to ignore batch again. I don't want to mix in dot product algorithm. It works in last 2 dimensions inside the batch. So again, it will look something like this. So the transpose, then do the dot product with the X chunk expand dim -1, and then when this is done, then we want to squeeze, eliminate the extra dimension. Squeeze dim -1. So okay, let's try to fix this code so that it works. You can consult with each other or look at the code from previous sessions where we made the dot product called multiplication. Again, what I'm trying to say is that here the kernel is now 2-dimensional, 1 dimension, 2nd dimension. Here the X chunk is again 1 dimension, 2nd dimension, but the dot product, this like add symbol. So the dot product will include the last 2 dimensions. It will include this thing and batch, but we don't want to include batch. We want to add here comma 1 and then do the dot product on those 2 parts, and then later eliminate it again. And then when it's ready, then we want to plug it in here in this part. So if you just implement that one line, you will get it working. So now I need to jump into this one call. Just a second, I will be back. Yeah. Hopefully it will not take too long.
Anyone have a clue? Describe it better.
I'm not even sure what the exercise is.
I'm completely lost, so I don't know on which point.
Isn't it like a bunch of multiplying next cybersecurity using machine learning, it's like really difficult stuff. So it's like
Oh,
Okay.
das mit dem Moderieren aus.
yeah,
Er kommt 20 Minuten zu spät, 10 Minuten da, no call.
Ja, das ist auch schon Also an keiner Stelle würde ich mir echt große Geld zurückholen. Das kann nicht sein.
I would just learn how to type faster.
Yeah, but we are lucky because we have kind of a scholarship, right? Actually, guys, you paying for this.
Oh yeah, that's nice. But still, like you all pay.
Yeah, because it's a time here, you know. We have a good time here. We're not talking about
I couldn't find the offer for bed and everything in Riga for less money. So
At least we saw Riga.
2 weeks in Riga for this money.
Yeah, but come on, this delicious food.
Everything.
food is alright. Food is fine.
It's an all
Yeah.
inclusive
Yeah,
restaurant.
That's why you guys remember me for that, yeah? It's really good.
Oh yeah, we go.
First to best, you're very good.
What? I
You'll be in my class.
He has to see all the
Yeah, I met you. It's like enough for me,
I
yeah?
never met a Serbian.
Yeah, they don't, yeah.
They are not anywhere.
Yeah,
They're very rare.
very good.
Also ich nutze das ja mal so. Wer ist natürlich so, ja mach mal das in schon.
Don't throw cows.
Ich habe gestern versucht. Oh mein Gott, das ist auch geschickt. Ja,
Don't play chess. Don't play chess.
Ich pack's jetzt aber in die Busse und muss rausgehen.
We play very well.
Alter.
We can play very well. Chess.
German.
Yeah.
Who plays good track?
Chess.
Actually,
Moldova is trying to find somebody to.
Chess.
on one computer or how are we gonna play? Is it on the or just the phone?
I have enough headache, I think.
This guy in my class, he's the best, comes 30 minutes late, 10 minutes in the work and then I do everything. I think everybody should just approach it like, like just. Hey, to use the computers?
Search your chess.
Let's
Oh,
wait
God.
for someone.
Oh god.
We put him on.
Wow.
So, bye guys. It was nice to meet you.
Is my annoying? Enough for today.
Yeah, for the full week.
I can't stand it anymore.
I would suggest this because
Nice. Yeah, to come down. Bye bye. Not what you should. We can run class. Probably right. Don't waste my time.
yeah, you cannot play.
Nice.
No, not this one. The other one.
The other one, here.
Yeah.
Hold on.
Yeah.
Oh, shall I put these here?
Cool, then I'll check what's inside.
Should have done this one.
Yeah, that's why it's
Okay, but okay, that's it.
It's okay, it's okay. Okay, one
I need smart guy. Smart guy. Where's implement?
You okay?
Who knows what we are supposed to do? No one.
Okay. Okay.
If you help me to
You can also advance like your other
install
tools.
NumPy because I have some runtime
Yeah,
error.
I would.
I probably know.
Maybe if he. Yeah, put it here so he can go here. And then with this pawn so he doesn't go either here. Yeah, see here. No, not here because if you go here he can put here or here.
Yeah, there is no
So
solution for that.
here.
Search tile must.
Maybe just go up by one.
This one?
No, not this. Yeah, maybe. I'm not sure. There's also a time. Oh my! Look at the time. Oh my God. Okay.
Wir können alle bestellen, dann kriegst du sicher was.
Yeah, and we have to open up this. It's clean, right? Or okay. Okay. If you do that, I can see why not. Yeah, I can see. This room. Yeah, we have to open up this. We have to. Okay, he's aiming either here or he wants to go here. If he goes, wait, if he goes here, yeah.
Professional. What? No, you cannot do it. You cannot do it.
Yeah, he cannot do anything.
We can open this here.
I would suggest maybe putting this here.
Or here or here.
I would if we go double, there's nothing threatening.
Yeah.
So we could.
You're good at chess?
We're 2v1 against the random.
I feel the fire.
Okay.
Let's do like chess compete. And then I'll
I don't like it, so.
I think
Okay.
scared.
I fucked up.
I thought it was the t-shirt.
No,
Don't you have your own laptop or something?
No, this one can't be like that.
Usually,
Because it's mine.
Yeah.
that's
high school.
Yeah,
That's high
the
school.
teachers
All the things.
so aggressive for nothing. I think he's gonna switch up here. Like, you know, I don't know.
We can just, maybe to think before.
Yeah, but is it a good idea? Because there's nothing here.
We cannot do anything because if we attack, we get counter attack.
Oh, we can maybe just go with this here and then open up these places so we can go with the force.
I'm gonna add comma somewhere. They will never find that.
We have to be more fast paced because we have.
Oh, I'm gonna add some.
Yeah, but we have to.
Everything's gonna grow.
You have to add something which isn't broken.
It doesn't for us. Oh my god.
you're in trouble.
Oh, Keenan, remember I was talking to you about numbering the Polish republic? Yeah, it's stolen from France. France was the first one to do this. You're numbering the French republic. Yeah.
Wait,
What was the best ball movements in
Like, you remember when I told you about Polish republic number 3 or something? Yeah. We stole it from France. The France was the first to do it, and you still are doing it.
The number of what? I don't get the.
Like, it's the 4th French republic. It's not like France. The official was like.
Oh, yeah, it's like.
Yeah, we stole it from Poland. Same stuff.
Eating you.
You started from
Yep,
us.
yep.
Yeah.
I could review as I was sure it was like Eric's. We went like the friends. We usually just stop.
Yeah.
Alright.
Okay.
Okay, I attacked this guy and he went back.
What was your
From here to here and then he from here to here. Because he went here.
So we can.
Use the go up and then go forward.
What are you going to do?
You really have to do this now.
If it's Cambridge,
Yeah,
sorry.
yeah, that's
Yeah, we have to get at least a ton.
let's get our goals up.
Better for your eyes.
Look at that.
And I can
Now the light. So if you're not in,
So
is it
You could-
bright
if you-
outside,
yeah.
you know, like on lamp or
Yeah.
like that, then it's much
Oh, wait.
better for your eyes. Stick with the light version of the
Yeah, of course.
Yeah, but
So,
it's
Tim,
because your eyes
What-
has,
what
if you're doing this in the dark mode and outside,
this,
with this kind of bright, then your eyes have to
so you have like a
so has to actually other lights
more
around
flexibility
you,
of this.
and this is much
Okay,
Yeah, but because I have my eyes closed all the time, and then I'm very interested. Yeah, I'm nothing.
Nikolai,
I have been so
do you love to join me in a chess game?
I'm on vacation. I'm on vacation.
Okay.
Next time we can play chess when you are at Moldova. I'm on vacation. No problem. But on vacation, I'm chill.
You know chess? Look what. Yeah, we're you'll probably just leave it all. Okay, you don't want to put this. If you take it,
Zero, what?
Someone said, I think it holds true, Pinochet looks exactly like our first object-oriented programming.
Yeah, I should write it like in the second day.
What about
When you say about the space again.
oh yeah, we put this
Yeah,
in.
but I'm not-
And then after this, put this.
And you know, just run for dormitory here.
I know chess, but I played chess when I was 5 years old.
Oh, you can't, don't move it.
Whatever I played chess when I was 5. When I was 5, I was in there. And so.
But now I'm
Yeah, because
No, I was
if you go here, if you go this, and this. Yeah, because this is what's second. Maybe switch. One eye, one you.
What, you are not eating there? You are not eating there when you are young? It's part of your
Yeah,
childhood.
just
We
do
don't know,
something.
maybe. It's part of growing up. Yeah. You have to at least one try to know
Yeah.
that it is.
I think he is time wasting. Yeah, he's time wasting.
Okay.
I mean,
Okay, he cannot eat. You have to push him out backwards. So if you, no, he can't aim for that. Can't because of this. You have to push him out. You can't push him out. Can you pressure?
Let's go. Noch nichts anderes.
Oh, yeah, yeah.
Oh. Oh look at one, and he can't eat this one. Yeah, now move this away. Move this away. We have very little time. He has to have let's try it. Maybe move it all the way here. Can you just lie down? Does just that count kick you out? I had it on the count. Okay, you cannot.
I can actually.
It's not a good trade. Oh no, he's going here. He's going here. You have to make some space for the fish.
So.
If you move here, yeah. So you need flexibility with this. Yeah. Then this has to be your next move. Oh, he's going double here. You can maybe if you put this here.
Okay.
No, not this. This here. Then he goes here, here. Yeah. That's a good. Because you're blocking his path to here.
So we have this.
Wait, what? 60. Okay. No. He's aiming for this. He's aiming for this. This is protecting this. So move it here. Go with here. No, not this.
No, it's like
Wait, I'm going to do this.
Yeah.
Takes it and take it.
the thing.
Is anyone
No,
implementing
but this
code?
one's protecting
Because
this.
the thing is sometimes.
Okay, he's aiming for this.
Hast du den Code? Gerade eben
I'll just
über
do this one and try to go.
Oh, jemand zu vergleichen.
Yeah,
Ich hab den schlechtes Code.
Okay.
Oh,
Wenn ich
yeah.
tatsächlich hier
Yeah.
wir sind ein bisschen unangekommen.
At least time out. Don't let him. Time out. Just wait. Just wait. Don't let him. It's because of time.
You cannot pick both.
Can I lost or no?
Yeah, he was. I
He did. Just
He didn't coach him. He didn't coach him.
after one super.
Is anyone trying to do this on my screen?
Yeah, I will finish. I want to compare them.
Oh no.
Oh.
Come on.
Oh,
You think I understand what's happening?
Okay.
Okay, I never understood this game.
You know this?
I've seen people play it, but I never understood it.
Yeah, I tried.
Actually not.
Like,
Well,
basically, I'm not getting it because it's like only the
the numbers are it's on the square so you notice
Oh, okay. Yeah, okay. So you just remember that.
not random this. So basically you have to so
Yeah, can you show the entire code? I have to think about it. I haven't thought about it just implemented.
here this will be one two
Okay, we
one so one and here one
How often
This is just one of the first
I think he's just testing all parameters and trying to reshape it in a way so that you can later on pass the data set to the models that go as
Mark this
yeah
I think because of the screening stuff, only that the models can later on work on different things. I think that's
there's one here that's for sure
I mean, I don't exactly understand how many words are supposed to like that this kind of code, the comment, so it's like the stuff, so it's like already pre-code, shouldn't be the last. Actually, oh, okay, we could do this, but are we going to chunk or what? Because we don't have like variables other than this chunk.
I think the X chunk is the it's
No, check.
the chunk like
Oh, yes.
the
Yeah, sure, but
the
why?
bit in the feature map.
Yeah, but why?
Yeah, what you play along with your
chunk is in and chunk out.
yeah sure right
Yeah, you play.
I go first
Yeah, you play first. Oh, you play
According
first.
to like all of this kind of like expanding and you have in and this part here.
Maybe we will find out soon.
Thank you. Sorry, nobody cracked this yet, or did you try at least? So anyone try to use
At least it's not crashing.
the unsqueeze functions and functions in the PyTorch? So here the solution is basically so it's not really one-to-one need to be rewritten, of course. So here the transpose is written there is actually torch transpose thing as well. Transpose. So transpose means to rotate matrix 90 degrees. So or to change the order of those two dimensions. Okay. So torch transpose input. Let me see. We cannot give it. So yeah. So then this will be the k, or we could just write it actually. Maybe let's write it shorter. So it's basically k means transpose. So that's that. So then the other thing is we do the dot product with x chunk, and here we need to unsqueeze or expand dimensions. So that's the same code I already shared you with when we built these classifiers and regression models. Unsqueeze I hope this is correct. So the unsqueeze last dimension. So this means please add me the third dimension to two-dimensional matrix so that the dot product works to the last two dimensions and do not mess up the batch dimension. Because otherwise I can make it work also with two dimensions, but then it will definitely damage the batch. So squeeze dim -1. But what it means is that damage is that it will learn some nonsense because it will include the batch inside the calculation. So let's try to run it. I really hope that I did not mess it up. So yeah, it seems to be working. Seems to be working. So I will put all of this huge block out. In the slide number 5. So for you, actually, it's just one line need to be added. So otherwise, it should be working. So now, if I, yeah, let's try to make sure that your dummy code works so far, and then we will build the first proper model, and then we will train the classifier, and then I will give you actually the template with the captcha, and you will be able to start trying something out with classifying captcha. So what is about this? Is it working so far?
Yes, that's the same error message as in the beginning, but I think it's expected.
Yeah, sure. Except there is something off. See the gray ones, if you see anywhere gray, it's something not good. So see the gray one says that you're not
using it. Yeah. But can you have a look at the my approach? It's the ball.
For this one? Yeah, this looks good. Yeah.
So that I don't have the exact same.
It looks very good, very good. Yeah. So I think it should work. Just make it that you all yeah. So the plus sign, see?
Yeah,
You don't need it. Yeah. No, don't touch it. Just put it. Yeah. So go there. Yeah. So here there's. So let me see. So first, just like next chunk, right? So first of all, one thing is not good. See, the tab is not right.
Okay.
So if the tab is not right, nothing works. So that's one. Then the K, small K, large K. Right? See? So small K. No, it's already small K here. See? So otherwise, it seems to work, right? Okay.
Something about dimensions.
Yeah. So we'll go to the K-mean uniform.
Use the follow.
You're missing the follow. What?
Use the follow. So I already asleep.
No. So here, there's not kernel, there's not a file. Remember the kernel, it should be like a box, right, and things like that. So if you look maybe at
delete the unnecessary stuff. Delete the stuff.
I don't have Twitter, and there's nothing on this. Everything is broken.
you can try to run it maybe also on Google Code. You don't need to.
Yeah, it is in Google.
Yeah, we need to show
I need
you
new
that.
SSD.
Okay. Oh, it's downloading now? Yes, sure. It's just downloading the data. So by the way, we'll write down, but you can also see there is, if something is not working on your computer, there is the Google Colab. This is kind of Jupyter notebook on the cloud, but this is even better because on Jupyter is basically the Python version of you can write it in kind of like a report type of style. And maybe I can show you that as well now. So I'm adding this code to the slide number 5, so it's not missing. Okay.
It's the computing in Google Colab for free, or do
Yeah.
you pay? Really? Okay.
So it's very good for computing. So here the Google Colab. So opening in these cells, you can just write Python code and execute it without the Python installed on your computer. You can also import NumPy because, like, I know some of you don't work NumPy, but here it works, no problem. So and then here there is one great thing about it is change runtime and put it to GPU, so they give you free GPU as well. So yeah, what's the only thing that there's written that if they catch you doing the mining, then you're out. And there is also all sorts of other restrictions, like for example, you cannot run 2 experiments at once. Like you cannot, it must be open, window must be open, and things like that. But otherwise, like a very nice way to do the coding, if you don't have GPU on your computer and you want to test something out, or some libraries doesn't work. So definitely Google Colab, you can use it. Just a second. So yeah, so Google Colab, write down. And the similar services are also for the JetBrains as well, but they want you to pay at once. But Google Colab allows you to give GPU for free initially. So
Initially.
yeah, no, I mean like you can use it. Because when you start doing like a lot of experiments, it's you would like to subscribe. So go to that line. So you're using the here, the padding you show up the padding here. So now everywhere is self, one padding, there's not self. See?
So I need to add self.
Yes, yes. Okay, let's go to the code. Let's try to make this workable as soon as possible. So then the batch norm function is something which will not yet implemented. Maxpool not yet implemented. The model is something we want to implement. So let me see. First of all, before starting to run it, I want to check what is the size of the images here, the apples. The apple size is 28 by 28. Okay. So the input size is 28 by 28. Okay, so the in size will be 28 by 28, so we know that. So then then let's write the encoder. So the encoder is called this model which tries to reduce the size of that feature map. So then the convolution 2D in channels, initially 3 channels RGB. So then out channels, let's try to make it larger. So then 4. Then the what else? The kernel size. You can quickly actually check out. I think we can reduce the size by doing this kernel size stride 2 padding 1. Let's double check that my intuition is correct. So then the out size after the first layer. So this will be the get out size, the in size. Then what was the parameters there? Parameters. Padding kernel size. Okay, padding 4 kernel size. Padding 1. I don't like it. I just would copy the same stuff here. Like that, and if I add here a breakpoint and want to check what's happening, so I added just 1 layer of convolution. Yeah, so the output is 2 times smaller, so that's great. So we got from 28 to 14. By the way, these lines which I wrote up here, you don't need to write them because these are just calculations of the sizes, but if you want to create your own model, then of course you need to follow them. So here, initially the size of the input is 3 by, so maybe let's write it up here. So the initial size will be, X size will be 3 batch by 3 channels, color picture, 28 by 28. Then after this guy, we'll have the size of 4 by 14 by 14. Now we will add the non-linearity. So torch and leaky relu. By the way, leaky relu is a little bit better than relu. By the way, again, that just from the experience and from years of research, any activization function is not better than other activization functions. This is the easiest target for research, and there's like hundreds of papers, maybe thousands of papers trying to find the best activation function, and they never find anything better. So the leaky ReLU just allows us to not have dead neurons. I will quickly let me explain what means dead neuron. So when you train the model, it's very easily possible that you can run into problem of dead neurons. So let me find you what I mean. So the leaky ReLU. Let me find example. So here's the second. Copy image. So because now we're adding the leaky ReLU, not sigmoid. So here's the difference. So on the bottom part there is the classic sigmoid, right? So then there is the classic ReLU, where everything which is on the minus side in the input becomes 0. But then the problem is that gradient from this part will become 0 and nothing will be learned. So if by any chance the projection put my data point here, then this becomes a dead neuron because it will never have any gradient for the weights to change. The weights will never change for all the variables on this end. So that's why they often use the leaky ReLU with a very, very small slope here, like let's say 0.1 here, the addition. And then the gradient will slowly go to that direction. So, but at the end, like in reality, it's very, very small difference between this and this, but this is better. It's at least giving you a little bit improvement, but the improvement will not be huge. It will be very small improvement. So that is why it's needed. If I go back here, so the leaky ReLU is added. So now we have the batch 414. Now we make it smaller feature map, right? The smaller feature map will be then again 2 times smaller. This exactly the same code copied, only the in channels become 4, out channels become 8. And now this guy will be batch 877. Batch 877. So okay, let's double check that all of this equation works as expected. I will add here a breakpoint. Try to, oh man, sorry. Try to make sure that the output of the 7, so it will be 3 then, yes. So then 3, and afterwards will be the 1, but it will not be good because there is the stride. Okay, let's go until 3. So then I will copy all of this thing again, and now the output will be 3, 3, and this will, let's make this as 10 or maybe 12, so just like it's similar. So 8 in channels 8, out channels 12. So now we are reducing the size of the image by 2 every time when we run the convolution. Now at the end what we have is 12 by 3 by 3 image, and we need to add it here as an input features 12, 3, 3 like this. So I need to check how many classes do we have in that model. Is the class count somewhere. Dataset full labels. Oh shit. Fruits dataset labels. How many? I think there was 4 types of fruit, but I need to double check. Okay, I don't. Okay, let me. We will quickly add a breakpoint up here and scroll back to that place, and just want to find out how many classes do I have. Of course, I can just take the class number from this vector, but just for you to know where it is. Oh no, seriously, there are 67 brands. Oh no, so alright, so this is not apples, this is fruits. Oops, I thought this was an apple dataset. Okay, there are 67 types of fruits. Okay, then it makes sense to actually take it from the labels. Okay, 67 types of fruits. Let's go to the model. So here the output features, we need to predict which class it belongs. So len, dataset, full, labels, so this will be 67 types of fruits. In your case, it will be characters in the, like in the CAPTCHA. So it's a letter A, letter B, and so on. So this is that. Then the execution. So here some kind of hidden vector, which will be then the H, and forward X, and this H should be flattened. So H flatten. Whoops. Flatten. I think it works without dimension. We'll see. So then y prim equals the self fully connected forward H flat. So now we have an encoder and the classifier part. By the way, all of these models, classifiers usually have encoder, huge encoder, and then classifier. Here only the problem is that we don't have softmax applied. So softmax can also be applied later. This is just a function. So softmax dim -1. It's not learnable parameter, so it can also be not defined in the constructor. So if I add a breakpoint, let's see if it works so far. Oh, sorry. Yeah, it works. So it works so far. I will share this model code to the Jamboard. Slide number 7. And then we are missing only the last piece of puzzle, which is the training part, which we'll also look at just a second. You can also see that we are using now the fancy Adam optimizer, so not the SGD, but Adam, which is a smarter optimizer. Can you please hold? And the architecture of the model is something that you can design yourself. Or another way how to do this is...
I think I messed something up with the indentation.
Yeah, cool. So the architecture also can be designed by looking at research papers. Just look what others do. So what's here? Indentation. So matrix, main matrix not defined. Go to place. We'll try to run this. So it seems like that. So can you go where the matrix is defined? Control. No? Go scroll up. So I think this whole block should be one down. No. Can you go? So
one tab more.
Tab back, this tab back, shift tab or
this
yeah. Try again. But remember that we didn't implement loss yet. Yeah, well, except model is now missing, so these things also.
Also one to the left.
Yeah, this three lines. Yeah. No, one more. Yeah. Oh yeah, so
yeah, I got some.
Yeah, that means that the loss is not important.
Should I delete this part?
Okay.
Yeah, please comment out or delete. Comment out maybe easier, then later you can return back. So if any kind of error, check it out. So model forward, what is this? So I'll take X. Okay, cool. Now it's going in. So encoder, go down. Yeah, so that's more. it goes next to it. Then what's happened with okay, there is the shape problem. Okay, maybe I have some problem, we'll see. Or it seems actually that your problem is different. So maybe go to the model definition, go up. So here the 3 to 4, 4 to 8, 8 to 12. Seems to be about right. Yeah, maybe we'll need to look. Maybe I have some error. I even did not run it further away. So then here we need to get to this place where the model passes the forward pass. Might be that I have some problem. Yeah, I also have this problem. The matrix multiplication issue somewhere here. Oh, it's not. It says that the size is wrong. Oh, okay, the flatten. Yeah, so this was my problem. I guess I should not use functions like without checking them. So the flatten actually probably does not do what I want to do it. Yeah, it just flattens everything to one dimension. So I guess yeah. So this is definitely not smart. So let's not use flatten. View x size 0. So this means the batch size and then everything else. So now it will work. Yeah, it works now. Just a second, I will go back to this code. We'll add this to Jamboard and highlight the line which I changed. So the name flatten usually means to flatten the last dimensions, but here it just flattens everything, and if I want to try to change the code, it will be unreadable. So okay, so this works. I changed this line. I made from flatten to view. So view means just change the way how we look at the array. It's too bad that there's no I cannot write anything here. This doesn't work. It works only on this
Can you maybe help out again? It's in a way.
I never tried one of these. We can look at, is that actually working? Oh, cool. Yeah, it does something to it. Okay, how can I get back to this one? Oh, this is definitely not where I want it.
Not implemented error.
No, I don't.
Can you maybe help me out again?
I will go back to the second. Oh,
Really
okay,
sorry.
cool. Now it's working. Okay, great. I'm just getting used to this thing. Clear the screen, yes. Okay, cool. So what I wanted to mention about the view, right? So if I have some kind of matrix where there is like 1, 2, 3 closed, there's like just 4, 5, 6 again closed, and then all of these operations like view, like expand, squeeze, so on, right? They do not change any time the data. They just change the layout, right? So you just can say that, well, please view this as the just one continuous matrix, and I can just create just like 1, 2, 3, 4, 5, 6. So this would be if this was dimensioned before. So there's the 2. So this is the 2, 3. Now this is just like 6, right? And then we can unsqueeze, put there like brackets in all of these guys, and so on. So right, you get it. This doesn't change data. It's all of these manipulations are changing just the layout. And the one thing just always remember, in all of these models, first dimension batch, and we don't want to include batch in any mathematical calculation. We want to repeat the calculation of batch at n times. We don't want to actually learn that we don't want to learn as a model that if this sample is in the batch location 1, then we need to do something. If it's batch location 2, then we need to do something else. That's not what we want. So that's that. starting to know how to use this thing. Okay, good. Let's go down to the loss function. So the loss function you already know how to implement, but I will help you. So this is the index part. We have the indexes already. Okay, let's then minus torch mean. Again, categorical cross entropy, of course. So then the y times weights times torch log times y prim plus epsilon to make it numerically stable, and that's about it. So it should work. So now it's starting to train to classify the apples, and not apples but all sorts of fruits. So the test loss for the train loss should decrease over time. It's a little bit messy right now. Yeah, the results, okay, I know why my results are bad. I'm not training it on the full dataset, but all of you who actually train this on the GPU, you will get the good results. So, but before so again, remember, I did not add those two device things. That's why it was not as good. So maybe we should add to device. So if you go back to the convolution, so you can run it on your GPU version and you will get much better results. So here I will add also in the Jamboard the exact places where to add it, and this is how you can fix it also for your own code. Every time when you get an error that this is not on device, you will just add to device. So here the torch zeros to device, then again torch zeros to device. I think only in two places you need to have to device. Let me double check. So to device.
Only if you want to use on GPU.
Yes. But you actually want to use it on GPU, because right now if I run it, I get very bad results because I only include very small piece of data. And if I want to include the whole dataset, it will run very long on CPU. So I'm adding this also to the slide number 8. And then those of you who have actually the GPU computers here, you can definitely try to run it. So to run it, you need to go up here and make sure that this to CUDA device is enabled. And I will come and help you. So this is one. Another thing is I will actually copy all of this code and run it for you in the Google Colab as well, to show you how you can do this if you don't have GPU devices available now. So if I switch to the GPU, switch to the screen here. Just a second, switch back.
Are you going to share the entire code in a notebook? Or?
No. But I will share more information, and definitely will give you the template with the CAPTCHA as well, so you can try to work on that. But before CAPTCHA, we need to quickly cover a few small steps. So let me show you.
It'd be nice if we could get this working before.
Yeah, that's exactly. I will go around and make sure that this works. So then here, I'm using the Google Colab, switch to GPU, save, okay, switching to GPU. Then I'm pressing connecting, so getting the GPU allocated. Then hopefully it will connect. Yes, connected. Then I copied all of my code just in this one cell. If I run it, it should download the dataset as well. So now it's downloading dataset. And afterwards it will try to train model with full dataset, and we will see if with the full dataset it works well on GPU as well. I will go around and help you out as well. Just a second. Okay, now it's training. We'll see if it breaks or not. Yeah, it doesn't break. So it's training, it works on GPU. So it gives me, it will be interesting to compare. It gives me the 16 iterations per second, and if I disable GPU, it should be much slower. And so after the first epoch, we'll see what we get. So this is a train, this is test. This is the accuracy very low. So the first epoch is like everything is red, basically, not wrong predictions. But then we'll see what happens after it trains over a while. So and the model, by the way, is very small model right now, but it should do something. Can I help somehow?
Yeah. Someone fix the error.
Okay, let's go. For model is missing required for function. Go to the model. Where is your model class? No, this up,
class.
Yeah. Go down, go. Go up. Here, see the so this guy also should be on the left. No, left. Yes. See? Now it is. Okay, can I help anyone? Yes. Just scroll down. Sure. What is there? Missing required. So it's I guess.
Here.
Yeah, there is not kernel size yet. It's shown. Oh yeah, but there's a misspelling mistake. So go see this is not, it should be EA, go there. By the way, I can show you. You can see that if you type this, see, it gives you the options. When you are at green. Okay, it doesn't give you that option. Okay, sorry, it should be like that.
I don't know.
Yeah, but it's not. It is. It's so. Are you training on GPU now? Yeah, because so close it. I can show you. So if you're not training on GPU, go up there. So on the top of the page. So I added this pack here. Maximum sample 300 if you're not training on GPU. That's why it's not working. So if you uncomment these lines, then you will try to run it on your GPU device, and it will include everything. 0 means include everything in the scope. So, but then remember to add those few. Can we go there? Go next. So see, add these two devices there, and then it should work in GPU as well. There is also okay, so almost likely. So okay.
It's not to comment. It's
So it's something
the last slide.
So there's the matrix 1, right? Yeah. Okay, good job. Okay. Wait a second. So you need to add as additional bracket because because it's not the shape. It must be a tuple, you know?
Okay.
Yeah.
Yeah, I guess so.
Yeah, see, this is already understands that this is a spelling mistake, see?
Okay, yeah, this.
See, it says, see,
Okay.
yeah, but but it's not Jupyter notebook, it is the Google Colab.
Can we import all this?
Yeah, like again, I will show you how to do it. So,
Oh yeah, but still.
so it's training very slowly, very badly for me, but so the Google Colab, you just copy your code in the first cell they give you and then just run it. But also in the runtime, change runtime to GPU here.
Aber läuft in Python?
Ja.
Okay, let's make a little bit more interesting model and then end for today, so that tomorrow you can start working as soon as possible actually on that CAPTCHA task. So here there are some blocks missing, which we will not have really, I think, time to go deeper in them. So the batch norm and then the max pool. But I will show you what they are, and then we can just implement using the, okay, I'm not sharing the screen, using the built-in functions. So without knowing how they work, there might be some issues sometimes, but at least most of the things you already understand. So let me find the example. So I'm back here. So the batch norm. Okay, we'll scroll. Sure. Just to bear with me a little bit. Okay, let's start with the max pool. So the max pool basically is also the kernel function. So, and the max pool allows you to reduce the image size without changing the linear projection. So basically, as you see here, if I have just a kernel, the same for loop that goes around. So this in this case, it says max pool with the 2x2 kernel. So the 2x2 kernel, let's try it too. So the 2x2 goes here, goes here, goes here, goes here. It can also go here, then here, and then here. So and it just selects the maximum value of all of those, and then it allows you to reduce the size of that image without changing anything else. Just that. So the idea here is that max pool allows you to kind of focus on some parts of image. If there is the cat, if you want to find the cat and the cat is located here, then or maybe here, then this will be the highest value region. Then you again do some kind of attention, the linear projection on that region. Again, focus on another region. But the downside for max pool is that the error gradient, the backprop, they will go only through this one cell here. So you lose all of the information around. So it's not always kind of the best solution, but especially if the task is to locate some features on the image. So this is the max pool function, and then the batch norm function is very similar to what we talked about, the standardization procedure before. So this will not be the whole story, but at least part of the story. So the idea is that if I have this high dimensional space, again the output, the input, and after a couple of convolutional layers, it can also work with batch norm 1D. So also for the one-dimensional data. After a couple of layers, all of my data points start clustering here, for example. So the situation is that after the ReLU nonlinearity, right, I will get these values somewhere around here. So all of these functions like to work around 0. So the batch norm's idea is to do the standardization and move all of these guys around 0 here. And this happens in between the layers. So of course we do this when we prepare data. With the image data, it's kind of easy because all of the data is just from 0 to 1, or we can make it -1 to 1. It's not like with the car price data, it was a little bit more tricky. And here in the middle parts of model, it's definitely tricky because we don't control what's happening there. Maybe all of our data is shifted all in infinity, you know. So we try to control this, make them be here. And to do this, it's again a little bit tricky because to do this properly, we need to lock all of our network. We say we don't train any of our parameters up till this layer. Then we aggregate all of the outputs. Then we calculate standard deviation and mean. And then we shift the data. This is not practical. Like we cannot stop after every change in the model and calculate the real positions. So to do this properly, then we calculate only the mean and standard deviation for the batch. So this is just for the one batch for those 16 samples at a time. Then we have this adjusted result. And then we have gamma and beta, which are learnable parameters, which tries to predict what is the actual real mean and standard deviation. So it's trying to approximate, to put the batch norm in a kind of task to learn what is the real location of the whole data set for this. Again, and there is also the problem that if you have just one sample here, if you have just 2 or 3 samples, then this part goes out of the window. So it should be quite a large number of samples. And which batch norm, I can show you also some research where it says that you need quite big batches to make sure that this works very robustly. So if you have small batches, then it can start damaging the model. Okay, so these are the 2 Lego pieces which we normally in the long course implement ourselves. But as you know, this is very rushed course, but at least gives you some insight. And we want to get to the CAPTCHAs finally. So to get to the CAPTCHAs finally, we need to let's try to make it then more advanced model. So what I suggest is we can just do this last model together, and then tomorrow start working quite right away to the CAPTCHAs. So here the model, I will call it model advanced. So this again will not be super advanced because there's better ways to do, but at least this should work much better than our dummy model. So here we can just use the built-in torches. Torch column, you now understand what it does. So in channels, 3 out channels, let's say 4, and then we will do something interesting. We will not change the size of the image using the convolutions at all. So we will not try to change the size of the image using convolutions, but we will use those maxpool ideas. So the maxpool functions. So, and also of course the leaky relu or any nonlinearity should be adjusted by the batch norm. So NN batch norm 2D num features 4, like that. So this is one of our nice blocks. Then we can start copy paste as much as we want. If we just change here the same channel count, if we want, we can copy or create a for loop to add these like tens of them. Yeah, all of them will work. So it doesn't matter how many you copy these guys. So then what we can add is the torch and then maxpool 2D. And here we also need the configuration that allows us to reduce the size. So to reduce the size, I suggest doing the 4 stride 2 padding 1. So this will reduce the size twice. So 2 times reduction in size. That's great. Now, again, we can add three convolutions. This will become quite large, I think. Okay, I will not add so many convolutions. I will add just these 2. So, but you can add 3, you can add 4. The more you add, the more capable the model will be. Actually, deeper models, the more accuracy you can get. There are some drawbacks which we will address tomorrow, but normally the deeper the better. So that's why it's called deep learning, because they discovered that if you make these models hundreds of functions deep, they can start work even better. So then this will reduce to the size 7 by 7, 14 by 14. Now we are here. Then what else we can do is, at the end, if it's 7 by 7, and this is the 16 dimensions, let's add another set of these guys. So this will be the last kind of, it's not deep, it's very shallow, but it'll be better. So 64, 64, 64, 64, 64. And finally, just to make it work, we need some kind of pooling method here. So adaptive average pooling 2D. This will produce the size of, so what we need, output size of 1 to 1. So the adaptive average pooling is really nice, smart, hacky function. So this function does exactly the same as the adaptive pooling, so for the average pooling. So this is a max pool. This calculates the maximum value, but we could do also the, okay, let's not confuse you, adaptive max pool 2D. So this is exactly the same as max pool, but calculates the kernel and stride itself. So this calculates the kernel stride and padding. Kernel stride and padding from the output size. Padding from output size. Very useful. Basically, it's sometimes easier to do that way than the other way around. So, and then here, of course, the only last thing is that this will be 64 input dimensions. So now I think that's about it for the kind of a little bit more advanced model, except you also remember to change it here below that you are using the new model, not the previous model. So, and I will run this on Jamboard just to see if this works a little bit better. And that would be a kind of nice challenge for the homework. I will add some extra information what to try out. But you will have, like, really, I will make sure that everybody gets it working, but you'll have kind of really working model, right? And then till tomorrow, when we start working on CAPTCHAs, maybe you can try to make your own model work better than this one, because I believe it's quite easy. You could just, like, make more layers, like think about a little bit the structure, so you can quite easily make it much better. So what I mean by better, let me show you. So I just added this model, which I will also share on Jamboard shortly, and I immediately got this. So basically just adding, instead of having like those 3 simple layers, adding proper like kind of structure, already get 94% accuracy. So and it's in just a few epochs, because making it just a little bit deeper and adding a little bit of structure. So not actually doing that much. So and if somebody wants, you can just replace the built-in convolution with our own convolution, and the result should be very similar. So I am adding this to the Jamboard, and hopefully you all can get on the Google Colab or on your GPU computers the good results. So this is classifying fruits from images, and this also allows you to train models that can classify the CAPTCHA letters, for example. And we will then actually build a model which properly classifies the full CAPTCHA without any specific letters, but the full thing. So yeah, I added this to the Jamboard. Slide number 11. And let me help you out, everyone, to get this working.
Yeah, I mean, firstly, the last model didn't work. We got the same problem.
Okay, I can
Something
help you
like
fix
that.
it. Okay, let's fix the previous one. Okay, so just a second. Oh, that is a good error to fix. So let me see. Just a second. This means somewhere two devices. So can convert to the device card. Yeah. So it's actually easy to fix it. So with each line is this. Okay. So add dot CPU before the the Y. So Y right the directory. So here in these guys. So the Y, for example, is right now located on the GPU memory. But if you want to get it back, you can write it in two ways. One is write it like this. CPU. So please bring me this back to the CPU, or you can just write it like just the CPU like that. This one will also bring it back. So it should work if that's this way. Oh, but wait a second. There's another issue. So running this on GPU. Why did it watch all tensor? So here is definitely missing two devices. Yeah, try plan. Yeah, it seems to be kind of right.
No, I mean, it's not the same like.
Work with the
Yeah,
same keyboard.
it like uploaded and then.
Well, but it's not uploaded.
Oh, it's raining.
Yeah.
Oh, I guess.
Yeah, I can help all the zone users if it's working. Okay, what is the error? So forward. Scroll down a little bit. Okay, let's scroll down a little bit. Okay, yeah, so this means that somewhere is the sizes are not the case, we'll go in the model. So it's not even important to look at my code, you can look at your own because it will show you how. So we'll just go to the model. After, by the way, the numbers which I use in my model wasn't even exactly developed in the. So I think the problem is that the in channels and the out channels should always go in the, you know, like if this is in, this is out, this is in, this is out. See, this is 3 in, 4 out, 4 out, then there should be 4 in, see? And then the number of out, you can choose, you can leave it as that, right? But just make sure that they are in that order, you know? You get it? There's some place also.
Did you already run your code on the over there? Because I get an error in the forward.
Yeah, well, just a second. Yeah. Because I run this my code on Google
So it's
Code.
working.
Yeah, Google Code, it is working. Yeah. So yeah. So generators. Okay. So I need to see the code location. So it's not like this is the model forward. The output. Where is the line? We find the line. Search stack overflow. So some either can let you know where go off and start model. Yeah, so here there's I think it's red. It says here is the error, I think. So yeah, so see there is no in feature 64 because it's all feature 64. In feature 64. I will go to you as well, just other people are calling on the other end. Yeah.
You know to fix that.
What is the expand? What is the where is the okay expand? Okay, use the expand. Let's say can expand was a little no, you should not use expand definitely. Expand is actually I can tell you what is expand. Expand copies the pointers of the arrays and tries to put it in so if I have for example one sample which I want to be repeated n times, that is expand. Okay, where is the focus? So, yeah, so here this is this is just basic.
Aber läuft das noch bei dir?
So this means the model instance equals the
Oh, yeah?
new class of model.
Läuft das noch?
So we'll scroll up. So what do we have here? So you have model advanced. This is the one name. Scroll up. And you don't have anything else. So yeah, you should use the model advanced there. Yeah, let's use the next. This is the first thing. So I'm creating the instance of model advanced because that's what I have, right? Let's see then what happens next. Okay, now there's a problem with the calculation. That is better. So let's go to FC here. It says that if I want to pass this vector or matrix to that function, if it fails, scroll up. So see, there is the just one thing. So when you build these models, you can make it as you want, but the in channels and out channels should match. So if the in channels is 16, 16, 64, 64, 64, 64. So see, like if it was 4, then it is 16. The next one is 16, 16 to 16. Then here 16 to 64. Then again, so see the flow, right? And now when you get here in features, so this is something that is not related to 64. See? We need to change it to that to also 64. Can you help? Or you also the same thing? Yeah, can you help?
So, I've been an arrow in this board.
Yeah, this is I think the same problem. So this is minimized. So yeah, so see you're changing the channel count in input scroll up. So initially this is a colored image of 3 channels, right? Then we project it to 4 channels, then we project it to somewhere to 16, right? We're just increasing the size and always giving it to the next function, right? And now at the end there is this fully connected where there is the input of this, see?
Also, I have to adapt it to.
Yeah, you need to think what is the last output of that thing. So the last output is 64, and this is the output of 64 is just because we're using this active average or max pool, whatever, which creates the it will be the size batch 64,1,1.
Yeah.
So yeah, I just want to make sure that it works for all of you so far, so that you can be at the same line till next minute tomorrow, right?
No,
Yeah.
I have this.
Yeah, definitely related to this thing. So you correctly fixed your own idea of this. So this is great. But then there are 2 things missing. So scroll up. No, so you go answer. The first thing, this function is following the previous pattern, right? So here's the input. But then there's another thing. If you don't use the add average pooling, that means that your output then will be batched from 64 from some kind of size of the right? And then this thing reduces that size to 1 by 1 to 1, you know? So now it will be batch 64, 1, 1, and then you can just change there, you know?
Okay, so it's not 12, 3, 3.
Yeah, it's not anymore. We changed the core architecture, that's why it's not anymore that.
Okay.
So this is extracting the kind of encoded feature, and then we encode the last feature, we project the number of classes. So only those number of classes here are the fluids, right? But in reality it can be the labels of letters, you know, and things like that. So here it should be, yeah.
Yeah, I got some kind of
I
problem.
think you have the same problem as
I went to like every.
scroll down. So here, after the model,
Yeah, so it should be a long line.
so the thing is here, it's a little bit different model than previously. Previously we calculated what will be this vector size, right?
Yeah.
This time we're using this function adaptive average pool, or it can be adaptive max pool as well, which creates that we don't care about the size of the image again because we will reduce it last 2 dimensions to 1 to 1. So it means that batch 64, 1, 1.
Brauchst gar nicht anfangen.
And this is what we want to
Das hat das grundlegend schief gelaufen.
So that remember the batch is 1, right? So we care only about 64 times 1 times 1.
So it's gonna be like.
Yes, that's right.
Ich habe keine Ahnung mehr.
Yeah, I can try to go around. No, just okay. Good. One by one. Yes. So okay. So it says.
Yeah, I tried changing this.
Scroll down. Yeah. So see, this one is not
Das
used.
ist dein letzter Stand? Das ist dein letzter Stand?
Define it here.
Ja, ich glaube schon irgendwas schon 14 Uhr.
Out here.
Ja, das war das vorher.
Ah.
Ja, hab ich gesagt,
sounds
ich
better.
schnell verstanden.
So So in this convolution, do you mean kernel size? There's written. You go. You will look at that just a second. So the kernel size domain or convolution kernel attribute. Okay, yeah, I think it's a problem. We'll go to that line that is for loop. This one. The for loop line. See the upper. Yeah, so this line which is highlighted the next previous one. So see that there you go by the stride, right?
Yeah.
There should also go by stride, not kernel stride. There is not.
This kernel.
Yeah, because there's no such stride actually. That will work, and then we can move on to the next part. So I think it will be fine. Because what you do here, you create the convolution, you create a dummy matrix, you pass it through, and you see if everything is okay, you get here. I think you already get there. So if you get there, this is working fine, yeah? Let's see. I think it will get there. And then what you do next is, so yeah, this is working great. So then you just comment out all these guys and move on to the next part, you know?
Was dort den To-Device-Stuff Felix? Was hat diesen To-Device-Stuff da eingebaut?
Yeah, two devices necessary to bring the GPU and back. By the way, this is something I think I forgot to mention many times is that often you get an error that you cannot do something to get it back, you know. So if I do some calculations here, you see I send the weights to the device. So here I send the weights to the device. And then I will, if I want to get back, for example, this would be weight on CPU. So then I would do weight dot CPU, or the same is if I do weight CPU weight to CPU, and I cannot execute the numpy part, so this will fail. So this will be error, weight error.
But why would you?
Let me show you. So if I do this, see, so this line is error. But this line is okay, so wait, okay, is wait CPU data numpy. So it's just an example, so that the data is located on GPU or RAM, and the numpy can only work with RAM part. So you cannot just directly do this. So from the GPU data convert to numpy. First you move to CPU and then convert to numpy, and the vice versa. So basically here also two devices that need to be. So what here need to be two devices because the loss out of this thing is you want to execute it on GPU. You don't want to execute it on CPU. That's why you need to make sure that all of the variables, everything is on GPU.
But why would you convert to CPU? I mean,
no, because you want to calculate accuracy, maybe, or maybe so. In most cases, like I don't know, like.
But is there any advantage to do it on CPU, not GPU? If you have the GPU.
Like in most cases, you can do all like the more you do on GPU, the better. So it's just that before we also worked a lot of things on the numpy, so I bring back the numpy, you know. At the end, the plot, right? Which you draw the matrix, the confusion matrix and things. This is all called the numpy. Yeah,
We didn't have to do that.
Yeah. This is it's working on
CPU.
Yeah, then drop you make it on GPU, so go close it, go up. So you see the lines on the front. Yeah. So if you want to implement that, and also let's see, check that we also have some other things. So then scroll down to the loss function. Loss here. We go with that one again, with that one. Only wait one. You see it was missing to the right. Go to the right. Yeah, so because it was on CPU. So now try to run it. Maybe it will work just like that. Now let's see. So should be working on all the something is also missing. Okay, this was the thing, so wrote the line. It says it wants to have the CPU there. So just y.cpu brackets. Well, yes, that's it.
Schau mal,
What?
da fehlt noch das gute Waage jetzt noch. In das Kernel
Yeah,
That's
almost
exactly that. It just pushes two more exactly. Now we will see probably a couple of epochs, but there is a problem. Your loss is minus C. Go to the loss function. Loss cannot be minus.
Just
without
6, 7.
So I think the minus sign is missing. So minus sign, yeah. Because it's logarithm. So
They can judge it.
now you training it and hopefully get quite good accuracy.
And they will judge.
So you can imagine you can change all sorts of input data, make it as you want it. Yeah.
Strange.
So yeah, so you'll get better results as you train it. Again, if you want to, so running on the GPU, you need to disable. So first of all, to run on GPU, scroll down. How about the place where you were the loss function? So here you go to the device, it's missing there. Just make sure.
Yeah, I know.
Here also just that zone. After the Y. Why? Because yes, not CPU, because now it's located in CPU device. So scroll up then to the front of the code, in the back, like the first lines of the code. Remember we commented out.
Yeah, I already know.
Yeah, now try to run it. It should run train on GPU now. So the go back there. There's the tabs not okay. Try running again. Okay, so there's
I saw
no, this is usable. So
Yeah,
just
just,
so
a whole world
I just
cookies,
put,
the internet cookies, the input you get. You know, like when you go to a site, accept all stuff.
Yeah.
yeah, but we can make this one work also on GPU. Go there.
This kid is
Scroll up. So put device there is.
Yeah, some stuff, the way they say it, some are actually, like, for example, petrol. It's a gas,
Yeah, because the rest scroll up.
gas,
Here is the rest.
gas, it's not.
Yeah.
Oh, yeah. Petrol is
You know, run it. Might work on
But
GPU as well.
I kind of disagree with chips. Chips are, I'm used to seeing guys.
Yeah, CPU missing.
Yeah, they're not,
there. Also, these are dummy, so comment out, this is not the actual code, you know?
Why is it?
I'm just giving you like examples how to move data, you know? So you comment out, it should work, okay? Yeah, we go, yep, good, yep.
Maybe they're going
Instead of having an arrow,
speak with you.
you want to see the message.
Just a second.
Okay. Yeah,
Okay, show message. Yeah, this is the GPU problem, go up. So we go to that place where the message, go back to the code, please.
Is there any
Yes, go up.
that you hate?
So let me show you. So this is to device, here missing device as well. Okay, set the parameter, object, to device, yeah. And then forward. Yep.
You also,
So here also to the
That's
device. It might work also there, but yeah. So initially I was thinking not to use GPU, that's why. Okay, now it should work. Okay, now in your case it's running with very small amount of data, not the whole data, that's why it doesn't make any sense, right? If you just complement those parts, it will start running on the full data set, because it is saying that just include 200 samples. And, but if you do this, it might need to be fixed something, we'll see. So it's hopefully starting up. Get outside. Okay, there's some buggy thing. So yeah, go. It's a wrong place here. Please remove that. So it should be actually at report zeros. So where you added it before, that's a calculation for the output side. Remember, that's nothing related. Okay, so this one we can fix. Can we go to that line, please? Okay, so we'll go between Y and data. We have the CPU with the brackets. So brackets like this. Now, still something left. Did you run it again or it's still
Yeah, it's from again.
zeros? Say here is missing to the rest. Yeah. So now, and the same words. No, yeah, go there.
And also
here the framing device. Okay, so here go to the line. So here we're going to list the CPU. So after Y and Y dot CPU brackets. CPU brackets. No, smaller. The brackets. So again, yeah, it's not too much. And I was training for you, so getting a little bit better accuracy of 42%.
Yeah, from the way you say now,
we probably also get 20% accuracy of one, so it will go up. And if you make it smarter model, it will go up. So in your case, if the accuracy is small, it means you're not using
flags
or now.
they detect and I was
So the level for that is enable. This enable, right? And you're using the first model or the more advanced one?
So I did it. I changed it.
Go to the model. There's a model there. Yeah, it is. To that, so go into the loss function.
So basically
No, it's just loss sales.
Oh yeah.
No.
Purchases. That's all it is. What's that? Okay. What's that?
No, it's not one.
And some of them don't speak English.
Ah, or
When you speak English, it's either the Japanese.
Okay. Which situations are there?
Seems about right.
Is it something like if the
It's very strange that it's running as a right.
answer is that?
Maybe it's
He's gonna ask a question like a confidence without
And then
first line.
Yeah.
So here, if you have to link to see already breaking, maybe that's
Yeah, but outside of the university,
that's working. Okay, just a second. Yeah, do you have a question or? Ready?
Yes,
Okay.
it's
Good.
my-
I will go to you.
Can you?
Okay. Yeah. CPU with brackets.
Yeah, I know.
You have to remove the exits.
Seems, okay, so first of all.
You have to comment it out.
Yeah, because that was just example, so don't use it, but
Yeah, it's all the way here, it works perfectly. Sorry.
This was just example, but in my example, unfortunately, I was not that. So, yeah, I need help here, so. Okay, so do you have GPU on the computer?
Yeah.
The,
I think I can send access. I think they also have all.
yeah, so I don't, don't expect it to have on this computer, but then you can run it on the phone anyways. So, basically, the problem you do is that here, see, the front, so this part says that, is it all data set or just 200 samples?
Oder kannst du einfach Copy
200
reinpasten.
samples, you cannot expect good results, right? So, if you, Yeah, so if you try to run all the code on Google Colab or on these classroom computers or somewhere where there's GPU, you know?
And like, do I need to link this to device thing?
No, like to the device is very important if you run it on GPU because then it needs to move data from the GPU and execute there. Google Colab, there also we have some other guys that you know to help you out to start running. It's not that hard, it's really easy. So yeah, go ahead. So first of all, 64 but then you have 64 plus also one decision. We can probably check like one by one.
Okay. No, like Mario was staying to the room.
And then also the model
probably go and find out.
so probably it's model last year or something.
Oh, yeah.
Find out. Okay, you're looking to fix at least two.
I think my
When they get to 15.
Yeah, you know, very unlucky with computers. So that one was bad, this one is bad.
So, but yeah, we nearly have the same code and
Yeah, you can run on Google Colab as well.
Yeah.
And on Thursday they will show like the authors I think will show you how to use the HPC, the supercomputer. So it's like from console to send the task, to see the results, things like that. So but okay, so that's good. By the way, if you can help out each other as well, there are some people who are a little bit lagging. So those of you who managed can help, you know.
Yeah.
So yeah. Yeah, so this means you're trying to run this on GPU, but there's some parts on CPU. So I think like initially, okay, so maybe I will just help you quickly. So here, sorry,
you done?
I'm trying to run on the Google.
Probably your laptop has no CPU because I've heard you
here
and
there's this for sending device with large others. So I'm sending this vendor to store it in GPU memory. So I'm sending this to store it in GPU memory. I'm sending this to store it in GPU memory. Now it will work. Try it again.
Okay, so let's say.
So the model, this is Python type of problem. It says that so the class, so it imagines one language model new, but that was not existing anymore. You changed it.
If you no, I don't know.
If you create a class, so you have a class up there.
So I'm the
or you imagine the class.
Okay.
Yeah. So now it's like this starting to train, so there's another error here. So here the output of the model is not this anymore, it's already 64, like that. Try to run it again. Okay, now there is another small error like device. So here, here was the thing which I was explaining that we need to move back to the CPU lesson. And this thing actually you need to move to the device. Yeah, so now it can work. It's just a little bit tricky, but make sure that, that in this final equation all of the variables are on GPU. Yeah, it's already pressed now. So now it works.
It's actually the same.